Welcome to this presentation about fusing Sentinel-1 and 2 data to model GEDI-derived forest structure of the Paraguayan Chaco. This is a presentation of a workflow that was implemented in Google Earth Engine. My name is Patrick Hasik. I'm coming from the University of Freiburg in Breisgau in Germany, and together with Emmanuel da Ponte from the German Remote Sensing Data Center, we are working in the GeoForPy-project to better understand forest cover structure for biodiversity conservation in the Paraguayan Chaco. The Paraguayan Chaco is a complex ecosystem with especially high biodiversity. It's the largest dry forest on Earth. Since decades, there is increasing concern about the future and protection of this Paraguayan Chaco due to the expansion of mainly cattle ranching. So what is left over is a fragmented ecosystem with strict borders of deforestation, and you can see those patches of deforestation up here, those rectangular fields with wind barriers and forest islands. So coming to the methodology and data, so to model forest structure of the Paraguayan Chaco, Sentinel-1 and 2 data was combined with GEDI, which stands for Global Ecosystem Dynamics Investigation. This is data from the first high-resolution LiDAR that is attached to the ISS, and it's capturing canopy height and total canopy cover. So processing was done in Google Earth Engine and Python, and since we're dealing with a really large study area, you can see it here, it's the western part of Paraguay. This cloud computing capability are especially beneficial for our approach, and a tile-based approach was implemented similar to other studies. So in the following I will present the workflow. So data is Sentinel-1, Sentinel-2 and GEDI. Data was pre-processed, so speckle filtering and terrain normalization for Sentinel-1, cloud masking for the optical sensor, and quality and temporal filtering for GEDI. To capture the forest structural parameters using the multi-spectral data of Sentinel-2, several vegetation indices such as NDVI, EVI, tassel cap and others were calculated. Since we are dealing with multi-temporal data, so data for the dry season 2019, which ranges from June to September, percentiles and other metrics have been calculated. For model training, 90% of the training samples were used, which is roughly 67,000 samples, and 10% were used for validation, which is a similar split ratio to other studies. For modeling, a random forest regression model was used, and hyperparameters were tuned per tile. For model validation, several efficiency criteria were calculated, such as the coefficient of determination, root mean square error, and others. Main outputs are maps of modeled canopy height and total canopy cover, which I will present in the following, and other modeled results are plant area index and Foliage-Height-Diversity-Index to really define the forest structural composition of the Paraguayan Chaco. So this is a map of preliminary results of canopy height. Values range from about 3 meters to 21 meters, and highest canopy heights are located in the northeast, which is a more humid climate, and in the south and east. And the lowest values outside agricultural fields are located in the northwest, which is a more arid climate. And model accuracy is about 1.5 meter according to mean average error. Root mean square error amounts to 2 meters, and R squared is slightly above 60%. Model total canopy cover ranges from about 0% to 77%, and total canopy cover is understood as the vertical projection of canopy material in a certain area. And highest total canopy cover is again found in the area of highest canopy heights here in the north and east, and in the south and east. Lowest canopy covers are found in the agricultural fields, and outside agricultural fields it's again this arid region here which presents lowest total canopy cover. And model accuracy is about 6 to 9%, and R squared value was best with about 63%. So for discussion and conclusion, this cloud processing approach in Google Earth Engine really facilitates the analysis for this large study area with a huge amount of data. It reduces the amount of storage needed on the local computer, and the combination of Google Earth Engine and Python is really powerful, since you can convert those data objects and you only download final products using this workflow. So to sum up, it's a time-efficient processing. There's more time for analyzing and interpretation. So this was the first space-borne assessment of forest structural characteristic for the Paraguayan Chaco, and interviews that we conducted with forestry experts of the National University of Asunción confirm our findings. So coming back to the objectives of GeoForPy, there's continuing deforestation, there's monitoring needed, so for example to assess forest structural parameters in the Paraguayan Chaco to promote environmental sound land use. And further research that will be conducted in the GeoForPy-project is that we will rerun the analysis with an updated GEDI dataset, so it's more accurate according to geolocation. We'll test other percentiles of canopy height, such as the 90th and 95th percentiles, not the 100th percentiles that we used right now. And we want to validate our results with ground truth field data. So thank you very much for your attention, and if you have any comments or questions, please feel free to contact me.